Welcome back, team, to another Team Talima video. I am super excited to go over this next set of notes with you all. We finally made it in our Udacity React Developer Nanodegree to the Redux section. So technically this is section 2 of 3. The third one will be React Native, which is a completely different platform because that'll be for like mobile applications. But Redux, in the professional world, my understanding is it always goes hand in hand with React. And what Redux is going to do is help us manage our state. It is a state management package, library, tool. It's really awesome. So, going over Redux, I have not been through these notes since creating them, so hopefully I'll be able to understand the jargon I wrote down here. I'm sure we will. I'm sure we'll make it through this. There is a lot. I think there's 12 pages. We're on one of 12 right now. We're going to be going through the first 6 in this video, and the next video will cover the next 6. So we'll be getting through all of it. What I really have enjoyed from the Udacity Nanodegree is that they're not just teaching you to like install and use Redux. We actually went through and built through various exercises, built out the entire Redux library. Like, I know how the library itself works, and that was really awesome. I didn't fully understand we would be doing that when I started this section of the course, so we would write all this code, and then I just went back and ended up deleting it, which was fine, but it was a little bit of like a buzzkill at the time, but it was really great in theory because I now understand how the entire package, how the entire library works. And that's what I took notes on here. So hopefully I'll be able to explain this to you guys and we will together learn Redux. Not just how to use it, but what it is and how it works. So moving forward, we'll get through the first 6 pages of our 12 pages of notes today. React 4.1 is managing state. The first lesson kind of is an overview. So Redux can be challenging to learn, and the way they were explaining it is it's usually people try to tackle it all at once. So they learn Redux, they learn React, they learn React router, they learn the react-redux bindings all at once. React is not necessary to use Redux. Redux can stand alone, completely on its own. I believe it was originally created to pair with React and be like a helper library for the React library, if I'm getting that correctly. But you can definitely use it on its own. It does not require React at all. In this section of the course, we went over managing state with Redux, how Redux interacts with the UI, Redux middleware, which is very cool and necessary, in my opinion. We have Redux with React, we have asynchronous Redux, we have the react-redux bindings, and then we have the real-world Redux application. I'm actually halfway through this one, so we're just going through a real-world project, like how you would plan out the project, design the project, and then begin developing a real-world application using React and Redux. Then we move on. Improve the predictability of state in our applications. This is the entire point of Redux. One of React's biggest strengths is its state management abilities. Redux takes that a step further, and it makes it even easier to manage like big data, like global data. So it improves the predictability specifically through a lot of use of pure functions. And if you don't know what a pure function is, we'll get to that later in the notes. And the idea behind a pure function is if you feed in the same arguments to this function, you will get the same result every time. So if you feed it in a 1 and a 2, it's going to result in 3 every time. If you feed it in a 5 and an 8, it's going to result in 13 every time. Like that simple addition function. But that's the idea of a pure function. The same arguments will result in the same result every time. And that's very predictable, so you can predict the state of your applications. Redux helps you do that in large part through pure functions, but also it helps just organize how you access your data and what is called the store. We'll get to that shortly. Store data outside of the app UI. So if you're just using React, your entire state is within the React components, which is effectively the UI of your application. So we're going to learn to store our data outside of the app's UI. All data is in a single location. This is another React principle as well. Like, you remember the single source of truth? Redux follows that same principle. So all data in a single location. It's an object referred to as the state tree. The state tree plus 3 ways of interacting equals the store. So the Redux store is the term you will most often hear, and what the store is comprised of is the state tree, which is the data object itself, the JavaScript object holding your data is the state tree, plus 3 methods of interacting with the state tree. You have get, you have listen for changes, and you have update. And those have more proper names as we will go along here. So those 4 pieces equal the Redux store. That's what Redux is, essentially. The state tree, getting something from the state tree, listening to the state tree, and updating the state tree. So moving on from that, creating a store, creating a Redux store. You create let store, get state, you can get the state of the store. Subscribe is our listening method. So we have rule number 1, only an event can change the state of the store. We have a collection of events. Only an event can change the state of the store. That is the only way to update your store with new information, or to update old information and make it new, or to update old information. Objects that keep track of specific events are called actions. So JavaScript objects that keep track of specific events, like event types, are called actions. That's another term you'll hear a lot. We have action objects. For short, you call them actions. Every action object must have a type. It must have a type property. So that is how, we'll get into that. Every action object must have a type. I don't have the word here yet, but what we will be doing to update our store is dispatch. Dispatch is the method. So we're going to dispatch, and then the argument we're going to pass into that method will be an action. Every single action object must have a type so that we know what kind of action we're dealing with. Action creators are functions that create/return action objects. An action creator, another term you'll hear a lot, is a function that returns an object, an action object. So it returns an object that has a type property. That is the simplest way to put it. So only an event can change the state of the store. We have collections of different events, objects that keep track of specific events. So each specific event can be referred to as an action. And every action object must have a type property. And action creators are functions that return an object, return an action object, and of course if they're returning an action object, what they return must have a property, must have a type property. So moving on to lesson 4.1.5, Redux is a predictable state container for JavaScript apps. I'm moving my mic, hang on, there we go. A predictable state container for JavaScript apps. That's what Redux is. Update state with a function which takes state tree and action parameters. Yes, so I believe we're moving on to reducers, if I'm not mistaken. Yes, so in order to actually update your state, so remember your state, also referred to as the state tree, is just an object. It's a JavaScript object. To update your state, you use a function. That function is going to take in your state as one argument and take in an action object. So basically it takes in 2 objects. JavaScript object, which is your state, JavaScript object, which is your action. Rule number 2, the function that returns the new state needs to be a pure function. So the type of function that we're about to discuss and are discussing now, that must be a pure function every single time, is called a reducer. I'm sure that term will come up soon. Yeah, down here I use the term. So the reducer, when using Redux, reducers are the only functions that actually return new state, that actually update your state. That's what the reducer does. So you dispatch an action, which calls the reducer, and then the reducer is the function that actually makes the changes to state. Pure functions are functions which have all 3 of these characteristics, all 3 of them. You can't just have 1, 2, you have to have all 3. So a pure function returns the same result if the same arguments are passed in. Kind of went over that already. A pure function depends solely on the arguments passed into them. It doesn't reach outside its scope to get any kind of global object. It only uses the arguments passed into it. A pure function does not produce any side effects. So even like console.log would be a side effect. If I'm stating this correctly, like it produces 0 side effects. Pure functions do 0 side effects. They only return a result based off of the arguments passed in and solely on the arguments passed in. So moving on from those requirements, functions which take state and action and return a new state are called a reducer. So these are our reducer functions. They take state, they take an action, they apply that action on the state and return a new state. That's what a reducer does. All reducers must be pure functions. I cannot emphasize that enough. If you take away one thing from this video, from these notes, your reducers must be pure functions. That's the thing to take away. Otherwise, you're just really negating, if not the whole point of using Redux, the 90% of the point of using Redux. The point of using Redux is to improve the predictability of your state. In order to do that, your reducers must be pure functions. A dispatch is called with an action. So that's the dispatch method we were talking about. It is always called with an action. That's the point of dispatch. The reducer passed to create store. When you create your Redux store, which remember, that's the state tree, get state, subscribe to state, also known, like listen to state, subscribe to state, and then we also have dispatch to state, which is how we update state. That's your store. When you're creating it, you have to pass in your custom reducer function. The reducer passed to create state is called with state and action. Yes, so all functions update state with a function with a reducer, which takes state and action. This updates the state tree. Reducers update the state tree. They're the only thing which update the state tree. All listener functions registered with subscribe are called, yes, so this is part of Redux's functionality. Once the state changes, if you have any listener functions that you've registered with subscribe, all of those functions are now called. The way subscribe works, if I'm remembering correctly, is it basically calls back all the functions that you want to run every time your state has been changed. So this is when that'll happen. As soon as your reducer updates the state tree, all the listener functions that have been registered are called. So moving on, we have 4.1.6, we're testing our store. So we create store returns a store object. Create store must be passed a reducer function. Store object has three methods. We have get state, which gets the current state from store, subscribe, which provides a listener function to call when state changes, and dispatch. The store objects methods have access to its state. Yes. So these three methods have access to the state. Subscribing to store returns a function which will unsubscribe. Yes. So let's say you want something to listen for state changes for a while, but if a certain event happens, you want to unsubscribe it. Again, the way Redux has set up its subscribe method is that this function, if just called in and of itself, it will return a function which will unsubscribe you. So you can always do that as well. It's very simple. Very simple to unsubscribe and to subscribe. 4.1.7. Add actions, remove to do. So in our exercise, we added the actions remove to do and toggle to do. So these are our action objects, two new ones that we added. In our reducer pure function, you basically use a switch statement. And the switch statement will have different cases for every action possible for that slice of state. We haven't really gotten to slices of state, but to let you know, in a giant application, your state tree will have different sections of data. So you can have more than one reducer, which manages each section of data. You might have users, you might have, I don't know, a leaderboard, you might have like forum posts, blog posts, whatever you're using. And so you can have, each reducer will manage its own slice of your state, and each reducer will have a switch statement which with different action cases. It'll switch on the action.type, which is another reason all actions must have a type. And so if we are under remove to do, then it will update the state by removing the to do we passed in. Versus if we went to toggle to do, it would toggle the to do we passed in as complete or incomplete. That one's easy. I like toggling things because you can just set a boolean and then set it to equal the opposite of the boolean. Just put the little exclamation point, and it's awesome, and I enjoy that. I enjoy those moments. I don't know why, it's just a thing, okay? Add list of goals to our state. Add list of goals to our state, we create a new reducer. So now we're moving on from to-dos to goals in this little exercise app. And then this is the part where we created a root reducer, which calls the separate to-dos reducer and goals reducer. So I guess we did get to slices of state. We had 2 reducers in the exercise, one that handled the to-dos and one that handled the goals. The root reducer returns a state object. To-do goals return arrays. Yes. I hope I read that correctly. And then we had 4.1.8, better practices. So better practices in Redux change strings into constants. So if you look up here, we had actions that were called this. If you're going to be typing out remove underscore to do throughout your entire application, chances are you're going to use a typo. You're going to have a typo once in a while. So it is better practice to create a constant remove to do, which equals the string remove to do. Same for every other action object. So that's what we did here. And then we created our action creators. So it is possible to just pass in an action object, like just a JavaScript object. But again, that's not very scalable or feasible. So what we want to do is call an action creator every time we want to create or pass in a remove to do action object. So we created those functions, which basically they already had the type. So type can just equal the constant remove to do that we created. Plus you would pass in, then you would just comma and then the second property on the action object within the action creator function would be the to-do itself. So you just pass in the to-do object itself. Or in some cases, you can just pass in to-do.id because you want to pass in whatever information the reducer is going to need, because ultimately the reducer is the function that's going to be receiving your action object, and it's going to be applying that action on the state. So if it just needs an ID, just pass in the ID. If it needs the whole object, pass in the whole object. And that's pretty simple to create. Obviously the constants, and then the action creators themselves. Now we have like our actions set up, and our action creation set up, and that's set, I believe, until we get to asynchronous actions, or actions that have to make asynchronous calls, and we'll get to that later in the notes, maybe in the next video. Moving on to this, we have state tree dispatch. So now we're finally getting to dispatch. We're finally getting to the method that actually lets us update our state. It calls an action creator, which passes the type and update info. Yeah, so the action creator will be passed. Dispatch calls an action creator, and then the action creator is going to give us our action object, which will have the type and any info we've passed into it, like I just explained. It could be the whole to-do, it could be the to-do.id, whatever you need. In that particular case, we had a lesson challenge here. How is state updated in Redux applications? How is state updated in Redux applications? In Redux applications, state is updated by passing an action to the store's dispatch method. Dispatch then calls the reducer, a function, a pure function, and passes in the current state and the action. The reducer switches through potential action types and then performs the necessary change for the type of action passed. So hopefully you caught all that. Feel free to reread it. That is as straightforward as I could make the answer at this point in my notes. I really enjoy the lesson challenges. It helps you boil down what you just learned, so it's pretty cool. What is the store? The store is the entity or object which contains the state tree, all of our apps state/data, a method to get the state, get state, a method to listen for state changes, subscribe, and a method to update state, dispatch. So that is what the store is. Moving on to the next section, UI plus Redux. Let me take a sip of tea. Lesson 4.2.2. We created an index.html, added some UI, 2 inputs, buttons, functions, added to do, added a goal. Okay, so we're just adding some UI to our exercise here. Added event listeners to buttons, add DOM elements of to-dos and goals, add toggle functionality to click each to-do complete or incomplete, add remove functionality, appended the remove button to each to-do goal. Yes, added a remove button. We have lesson 4.2.4. We adding Redux now. Remove our custom store. So up until this point in this section of the Nanodegree, we built out our own custom store. with our own custom dispatch method, get method, subscribe method. Now we took out all that code, and I wish I hadn't deleted it. I wish I had just commented it out, because like a noob I deleted it, so I can't even go back and look at it easily. I mean, I'm sure Redux has excellent documentation, so I'm sure I could find anything I needed on their documentation. But we added Redux for Reals, the official library. We removed our custom store past reducers through redux.combine reducers. So when creating a Redux store, or we have our store, we have Redux, we have to create the store, we can do redux.combine reducers and pass in an object of all of our reducers, which just keeps our files a lot cleaner. I mean, you don't want one long switch statement and one huge reducer function. It is much better to break it down. So everything still works perfectly, we moved on. Lesson challenge. What are the advantages of using Redux? Redux does an excellent job of separating the views and models for applications. This enables their state to be managed clearly and efficiently. Single-page applications do not require server round trips to update their UI, which is awesome. Redux is an implementation of the Flux data layer pattern. I'm not too familiar with Flux, straight Flux, but I'm going to read up more about it because it comes up often enough. I want to know more about it and how it kind of came to be. So Redux is an implementation of the Flux data layer pattern and is a predictable state management library for JavaScript applications, which allows for easy implementation of logging, hot reloading, time traveling, and more. So we have done logging and hot reloading. I have never done any time travel debugging. So there you go. And more. I am being visited. I am being visited by a furry creature. Okay, short interruption by the furry creature, but we're good now. We're good now. What was I saying? Point 1 in the lesson challenge. We have allows for easy implementation of logging, which we did, hot reloading, which we also did, and time traveling. I have not done time traveling yet. I'm very much looking forward to it because it's named time traveling. I'm not even sure what that means, but you know, who wouldn't want to time travel? So, looking forward to that. Number 2, describe the 3 principles Redux follows. We already mentioned the single source of truth. Redux has what it calls a store. A store is an object that contains your whole application state in one place, a single source of truth. State is read only. In order to change state, you must express your intent by emitting an action via the store's dispatch. You can only read the state. And then to change it, you call dispatch with an action, which gets passed to the reducer. Then the reducer doesn't even change state. The reducer returns a new state. So that's how that works. Changes are made with pure functions, reducers. Reducers are responsible for determining what state change needs to happen based on action emitted, transforming the state based on the action data, and returning the new state. Reducers must be pure functions. In a reducer function, you should never mutate arguments, perform side effects, call impure functions. So this is what reducers must be, must have pure functions. Number 3, fix the 8 bugs in the file below. Okay, this was surprisingly easy because 1 through 5 were the action creator functions and they were all missing a type. So you just add in the type. And then we had 6, state was not initialized. In a reducer, when you first create your Redux store, you're not going to have state. So the first time you pass an action into your reducer, even if you're just handling your initial data, like initially loading of your app, you must initialize state to be an empty object, otherwise the reducer won't run properly. So you actually have to initialize your state as something. State was initialized as empty object, not as an empty object, as an empty array, if I'm not mistaken, at least in this case. Yes, because this was initialized as an empty object, and that was not correct. And then number 8 was return state length via .push, which push does not do the same thing as push returns the length. And what we wanted to return, I think, it was something else. It was like the object itself. Was it .concat is what we ended up having to use instead of push? Yes, it was concat. So that's what we changed. It was all good. Moving on, this is the last one we'll be going over. Okay, Redux middleware. I've known the term middleware for forever. I hardly ever create middleware that programs I would myself call middleware. I just don't really do that. But moving on, we're growing up. We're becoming more pro here. So we created some Redux middleware, and it was very cool, very useful stuff. So create Redux middleware function to intercept action before dispatch. True Redux middleware intercepts action after dispatch and before reducer. That is where middleware comes into play for Redux. You have dispatched an action. That action is going to reach the reducer. Without any middleware, that's the very next step. But if you want to add middleware, it will take place between your dispatching of an action, of a desired state change, and it reaching the reducer where it performs that state change. The same way, every time, only based on the arguments, because all reducers are pure functions. So you can insert stuff in the middle if you want to. 4.3.2, was there really only 2 lessons here? That's very funny. There was only 2 lessons here. Okay, well there we go. Create proper middleware and pass it to .createStore. Pass it to createStore. Redux.apply middleware, so this is another Redux method function. We pass in our functions. Middleware for Redux includes operations like producing side effects, logging. You can log with middleware. We created a very simple, very useful logging, like console logging method. It was very cool. Processing action itself, making async HTTP request. So you will use Redux middleware to help you process async requests. Redirecting the action to other middleware, and dispatching supplementary actions. So let's say you dispatch an action and it's a big deal. Whatever app you're creating, like this is a big action about to take place. Well, you could use middleware to like dispatch some other actions that depend on that first one if you want to. I don't think we did any of that, but this is a place where you can do that. You can use one action being dispatched to dispatch several others or something like that, some kind of chain of events, if you wanted to. Redux middleware leverages a concept called higher order functions. Either accepts a function as an argument or returns a function. The one thing I want to try and explain here is like the syntax they used, which was admittedly very odd. And when I say admittedly, not only am I admitting that, but the instructor of the Udacity Nanodegree even said it was odd. So the way this works is you will first call a function which is passed. It's either store, next, or action. I'm mixing up my keywords here. Then you call a third function, and that is passed. Either store, next, or action. But it's like a 3-layered function, and even, not only the Udacity instructor, but even the Redux creators apparently have said, yeah, they weren't so sure they should have gone with this particular way of structuring the Redux middleware. But they did, and they don't want to change it now because it would break everyone in the world who's using this library, and there's a lot of people using Redux. It would break the library if they were to update this, or because it's just that it's that much a part of their package. So I think that's what higher order functions is referring to in this context. But yeah, it's a weird syntax, but simple to use. You set up the syntax, and then in the meat of it, in the middle of that 3-tiered function of those higher order functions, you can activate your middleware. So it either accepts a function as an argument or returns a function. Middleware intercepts a dispatched action before it reaches the reducer. We already went over that. It's 100% true. We created a logging middleware, log each action being dispatched, and then log the state changes after the reducer has run. So this was very cool because what we did in our logging middleware is we logged the action being dispatched. So you get the action keyword. You log the action, just so we know what's happening, what's about to happen, what we're trying to have happen, and then we actually run it. We actually allow the change to take place, I believe is what happens, and then we log the new state after the action is completed, and then we return the new state, like to finish off the middleware, because we activated the change so we could log the result of the action, the result of the change, and then we return what the actual change was. It was pretty cool, very simple, only like 5 lines of code, maybe 6, but that was pretty neat. Redux.apply middleware can accept multiple arguments. You can use as many middlewares as you want. They will run in order. So logging is always like the last one you want. They will run first to last, however you list them. But you can have as many as you want. Logging you want to have last. at least the kind of logging we developed. Middleware is optional, completely optional. Middleware can be considered a third-party extension point between dispatching and having the action reach the reducer. Third-party extension point between dispatching an action and having that action reach the reducer. Write middleware to achieve the following behavior. Display an alert when a new goal is added. Display an alert when a new to-do is added. We added that middleware. It was very cool. It worked. I was all happy and proud of myself. Middleware is the suggested way to extend Redux with custom functionality. You can only add middleware when you initially create the store. This is true. So you're going to create your store for the first time, booting up the app, loading the app, you create the store. All middleware you want to use has to be passed in at that initial creation point. However, it is completely optional. If you want to add custom functionality to Redux, you want to improve your Redux capabilities, or just add something new, then it is suggested you use middleware to do this. And middleware will always activate between an action being dispatched and that action reaching the reducer. Middleware is in the middle. Alright, we have some cool links throughout these lessons. We have, I think, another 2 to 3 to go, but I'm going to stop this video here because it's already been a very long time. So, thank you so much for joining me today. I hope I will see you guys all next week. We will be streaming this week. I pushed it off because of Christmas, but as soon as I get through this last lesson, I'll be on to the second Udacity project. So I thought we could go through at least the designing and planning stages of our new project on stream together. So that would be really cool and really fun, and I can walk you through and kind of, hopefully you guys will want to join me learning how to build an actual React and Redux application. So I always enjoy that. Starting is often the hardest part. So if we can get the planning and the designing out of the way, then we can get into coding and know we're not wasting our time and having to refactor and debug later. I'm a big planner. I enjoy this stuff. So I will see you on stream later this weekend. I hope you enjoyed this video, and I will work hard to get the next set of Redux notes out before next Friday. We will see what happens. Maybe it'll be on Tuesday or Wednesday. So I hope I see you next week for another video, and this weekend for Stream Team. Stream Team. No pun intended, but I love that. I love that. So I will see you then. Have a good one, and thank you for watching. We're kicking butt, guys. We're kicking butt. I love this React Redux stuff. It is so much fun.